we present gradient descent in the ALPS, abstracted low-poly stylization, and fabrication. Low-poly stylization is the art of representing shapes and surfaces using a limited set of polygons and colors, and is widely used in many art forms or fabrications, including woodworking, stained glass, and embroidery. Our goal is to automatically generate low-poly styled vector images from either an input image or a text prompt. To make the results easy to edit and fabricable, we aim to give the user control over certain properties such as the number of triangles, as well as their quality. Additionally, we want to prescribe a given color palette. This is useful for fabrication purposes with a limited set of materials or colors. The output must also form a manifold tiling without self-intersections, a property that is crucial for editing and fabrication, and not guaranteed by previous work. Here we show some example outputs generated by our method. Classical approaches for image triangulation struggle to preserve shape features during downsampling, as they lack semantic understanding. Enforcing the preservation of shape details often sacrifices triangle quality and leads to narrow triangles or even self-intersections. We aim to find a good balance between quality, abstraction, and color adherence. Here we show our output in comparison with others when controlling the color palette and total number of triangles. Existing vector graphics generators suffer from a lack of structure between the used primitives, resulting in overlapping triangles. Rasterized image generators can replicate the appearance of shapes, but they fail to provide mesh guarantees, resulting in edges joining in the middle of a triangle or triangles being left open. We aim to achieve high-quality results with mesh guarantees. We introduce ALPS, a novel method that takes an input image and a color palette to generate a low-poly vector image for further downstream applications. The result is initialized by a Delaunay triangulation of the input image based on a saliency map. Our algorithm then iteratively optimizes the mesh vertices and face colors using a score distillation sampling approach together with mesh simplification techniques. Given the cake and pizza input on the left, we compare our output again with previous work. We also display our algorithm output when varying the input color palettes. Our algorithm allows direct control of the final number of triangles. Here we double the number of triangles sequentially from 128 all the way to 2048. We quantitatively assess both semantic and aesthetic quality through a perceptual user study involving 75 participants. Our results not only outperform the baseline methods, but are also applicable to many physical fabrications. Using our output, we can create faux stained glass window by laser cutting the triangles produced by our method from colored acrylic sheets. The same strategy can be applied to other materials, such as wood, where we further reduce the assembly effort by only fully cutting the edges at color switches. Our vectorized outputs can also be automatically converted to embroidery files, filling the primitives with satin stitches. Since we output a valid mesh, we can make use of graph algorithms in order to minimize jump stitches, making the fabrication more practically feasible. Tapestry crochet recreates images by assigning a color to each stitch. We use SD pixel to generate a baseline pixel grid crocheting pattern. An issue of this approach is that it involves frequent color switches, which is very time-consuming and error-prone. In contrast, the low polygon output of ALPS provides a more crochet-friendly abstraction of the input image. Each polygon can be crocheted separately, avoiding color switches altogether. Due to the manifold structure of our mesh, the assembly is also straightforward. The low polygonal approach is significantly faster to fabricate. We can also use our low poly output to cut stencils. The mesh edges are used as a feature-aligned support structure. Each stencil represents one color from our palette to be painted, and layering the stencil prints together reproduces our target image. By tracing the generated polygons and adding seam allowance, we can also create a sewing pattern for patchworking. The cutout pieces are joined via their shared edges. Since these are guaranteed to be piecewise lines of equal length, they can always be sewn together via straight lines, which simplifies the assembly process. Please refer to our paper for more technical details and results. Thank you for your attention.